Welcome back, Design Chuckies, to Mechanical Engineering Made Simple. If you enjoy the podcast, show your support with a like, a follow, or a comment. It's free for you, but means the world to us. Let's keep leveling up together.
Today is going to be a wild ride. Usually we are deep in the weeds of thermodynamics or, calculating the shear stress on a bolt until our eyes cross. But today
is different.
we are looking at the human side of the equation.
That's right. We are moving beyond the calculator and walking through the actual life of a practicing engineer. We've got a stack of sources here based on the concepts of engineering practice curriculum. And it turns out that being an engineer is, 50% math?
And 50% navigating a minefield of ethics, high-stakes interviews, and straight-up boardroom battles.
It really is a story about how engineering actually happens in the real world, from the sheer terror of the licensing exam to the conflict between building a sustainable future and, keeping the board of directors happy. So our mission for this deep dive is to answer the questions they definitely didn't cover in your textbooks, like what actually makes a project succeed or fail?
How do you even get hired in the first place?
Right. And what happens when the correct engineering answer clashes with money or politics?
We have a really comprehensive stack of sources here, ranging from hiring strategies, from industry execs to sustainability frameworks, and even a detailed case study on financing a skyscraper that honestly reads like a drama script.
Okay, let's unpack this. We have to start at the beginning. The barrier to entry. You graduate with your degree, you toss your cap in the air, you think you've made it, but you aren't actually a professional engineer yet, are you?
Not even close. And this is a huge misconception. In the U.S., just having a degree doesn't let you sign off on blueprints.
So what's the path?
The path to becoming a PE, or professional engineer, is a multi-year gauntlet. First, you graduate. Then you have to pass the FE exam, the Fundamentals of Engineering exam.
And let's be clear, this isn't a little pop quiz.
No, it is an 8-hour marathon. And looking at the pass rates from the source material, it's just fascinating to see the spread between the disciplines.
It says a lot.
It really does. For example, for first-time takers, chemical engineers were sitting at an 85% pass rate. They are absolutely crushing it.
But not everyone was performing at that level. I saw the stats for industrial engineers.
Yeah, industrial engineers were sitting at 61%. That is a significant drop.
Why is that? Is the exam just harder for them?
It's not about difficulty, I think. It's about breadth. The FE exam is brutal because it doesn't just test your specialty. You might be a civil engineer focused on bridges.
Or an industrial engineer focused on supply chain.
Right. But that morning session of the exam covers chemistry, computers, ethics, and engineering economics.
So if your college curriculum let you specialize too early, and you, forgot your basic chemistry, you're in trouble.
You're in a lot of trouble. You can't just stay in your lane. The exam forces you to be a generalist first.
So let's say you survive the FE exam. You aren't done.
No, now you're an engineer in training. You have to work for 4 years to gain experience, and then you sit for the PE exam. Only then do you get the stamp.
But before you can get that experience, you have to actually get a job.
And this is where we shift from the technical hurdles to the social ones. The sources included notes from executives at major engineering firms, presidents, CEOs, VPs of human resources.
And they were asked what they actually look for in a candidate.
Yeah.
This is where a lot of 4.0 GPA students crash and burn, isn't it?
It really is. They are not just looking for someone who can solve a differential equation.
I loved this part. There was a VP of human resources at a $200 million environmental services firm who laid it out pretty simply. They look for enthusiasm, obviously.
Yeah.
But they have this specific metric.
The glass of beer test.
The glass of beer test. It sounds so informal, doesn't it?
It does, but it cuts to the core of team dynamics. The question the hiring manager is asking themselves is, would I want to sit and have a drink with this person?
It feels a bit like a popularity contest, but it makes sense.
It's not about popularity. It's about tolerability. I mean, engineering projects can drag on for months or years. You are in the trenches with your team.
True.
So if you are the smartest person in the room, but you're abrasive, arrogant, or just painfully awkward to talk to, you fail the test. You become a liability to the team culture.
Okay, so personality matters a lot.
Yeah.
But you still have to answer the interview questions. The sources recommend something called the STAR method. Is this just HR jargon, or is it actually useful?
Oh, it's the gold standard because it provides structure to your answers. And engineers, they love structure, but they often struggle to tell a story about themselves.
STAR. That's situation, task, action, results.
Right. And it stops you from rambling. A bad answer to "tell me about a time you solved a problem" is usually vague. "Oh, I'm a great problem solver. I work hard." That tells me nothing.
It's just fluff.
Total fluff. But using STAR, you'd say. The situation was we were over budget on the HVAC project. The task was to cut costs by 10% without sacrificing performance.
Okay, much more specific.
The action I took was researching alternative heat exchangers and renegotiating with the vendor. And the result was a 15% savings, and we finished 2 weeks early.
That's so much more powerful, especially that last part. The result.
Yeah.
You're quantifying it.
Exactly. You have to quantify it. Don't just say it worked. Say how much money or time you saved.
Speaking of interviews, the sources also listed the top mistakes candidates make. And some of these made me laugh, but also cringe a little because they are so avoidable.
Painfully common.
Number 1 on the don't do list. Jekyll and Hyde behavior.
Oh, this is an immediate killer.
Being nice to the hiring manager, but rude to the receptionist.
It just shows a fundamental lack of character. If you treat people with less power poorly, you're not going to be a good leader or team member. It's an instant fail.
Another big one is the weak handshake. It sounds like a cliche, but it registers as a lack of confidence.
It's the first physical contact you have. A limp fish handshake sets a tone of passivity. And the other big one, please, for the love of engineering, turn off your cell phone.
The source material literally wrote that in all caps. Turn them off.
You would be shocked how often a phone buzzes or rings during a critical answer. It signals that you don't value the interviewer's time.
And there's a rule of thumb for rambling. Keep your answers to 2 to 3 minutes.
It happens all the time. You get nervous, you start explaining the technical details of your senior project, and 10 minutes later, the interviewer has forgotten what they even asked you.
Okay, so let's assume you aced the interview, you gave a firm handshake, you didn't check your texts, and you got the job. Now you have a stamp, you have authority, but you also have a massive burden.
This is where we get into the ethical compass. Once you are a professional, you are bound by a code. We have the fundamental canons from the ASCE, the American Society of Civil Engineers.
And this isn't just a suggestion box, right? It's like the constitution of the profession.
It really is. And Canon 1 is the most critical. Engineers shall hold paramount the safety, health, and welfare of the public.
That word paramount is heavy.
It's everything. It means that public safety overrides your client's budget, your boss's deadline, and maybe even your own job security.
That is a tough spot to be in. If your boss says, we need to cut costs on this concrete, and you know it makes the building unsafe.
You have to say no. And if they persist, you might have to blow the whistle.
Canon 3 struck me as well. Issue public statements only in an objective and truthful manner. That sounds like you can't just spin things because your client wants good PR.
Precisely. If a developer wants you to say their project won't cause traffic, but your data says it will, you have to state the data. You can't be a hype man. You are a guardian of the truth.
And Canon 5, build professional reputation on merit, not by competing unfairly.
It's all about integrity. But here is where it gets really interesting. Because in the real world, being a guardian creates conflict. You have ethics on one side.
And money and politics on the other. That is the eternal struggle.
And to illustrate this, the curriculum provides a case study called Financing a Skyscraper. It is a brilliant way to see how these abstract ethics collide with cold, hard cash.
I love this case study because the characters are so perfect. They are archetypes of the people you meet in every single boardroom.
So you have the board of directors, and they are terrified of risk. They want you to run a sensitivity analysis.
Which is just a fancy way of asking, what happens to our money if everything goes wrong?
Exactly. If the market crashes, if construction is delayed, how much do we lose?
So first, we have Ken B. Least. He's the real estate marketing expert.
And the names are significant here. Can be leased, can be leased. He is risk-averse. He fears demand is weakening. He wants a smaller building, maybe 800,000 square feet, low risk, get it done fast.
He's the guy saying, let's not get crazy here.
Exactly. Then you have the environmental expert, M.I. Green.
Am I green?
She is pushing for sustainability. She argues that tenants will pay 20 to 40% more rent for the prestige of a green building. She sees the long-term value, the moral imperative.
And backing her up is the architect. You pay me.
You pay me, a cousin of IMP apparently. She loves the very green idea because it's an architectural statement. She wants to build a monument.
But then there's the engineer, concrete.
Concrete, the skeptic. He looks at MI Green's proposal and he starts crunching the numbers. He argues that the green building costs an extra $100 million in construction.
And takes 6 months longer to build.
Right. And his counter-argument is brutal. He says it only saves $10 million in utilities. He basically says, look, I can save you $5 million just by cutting out the fancy architecture, which I'm sure you pay me loved hearing.
Oh, I'm sure.
And this is the core conflict of engineering practice. You have MI Green and you pay me pushing for innovation and sustainability, which aligns with those ethical canons about the environment. But you have Ken B. Least in concrete looking at the ledger and saying, this doesn't make financial sense.
So how do you resolve a fight like that?
Yeah.
You can't just arm wrestle for it. You need math.
You need the math of decision-making, specifically project evaluation using equivalence and net present value, or NPV.
Okay, let's unpack NPV, because this is the tool that decides whether the skyscraper gets built or not.
It all comes down to the time value of money. The core concept is that money today is worth more than money tomorrow.
Right. If I give you 100 today, you can invest it and have more in a year. If I give you 100 in a year, you've lost that opportunity.
Exactly. So when concrete says the green building saves $10 million a year in utilities, that $10 million in year 20 isn't actually worth $10 million today.
You have to discount it.
We have to discount those future cash flows to see what they are worth right now. The source gives us the formula for present worth. It's M divided by the quantity 1 plus I to the power of N.
Okay, let's break that down. Dollars is the money you get in the future.
I just is the interest rate.
And dollars is the number of years out.
Correct. So 1 plus I sin N day. Because that 1 plus I in DIL is in the denominator, the further out in the future you go, the larger Donald gets, the smaller the present value becomes.
So that 10 million saved in year 20 might only be worth a fraction of that in today's terms.
A tiny fraction, which puts the green team at a massive disadvantage. Their costs are up front. That extra $100 million for construction happens now. Their benefits, the utility savings, happen later.
This is why sustainability is such a hard sell in traditional engineering economics, isn't it? The math naturally favors low upfront costs.
It favors the cheap and dirty approach unless you can prove the long-term value is just massive.
But the board wasn't just worried about money. They were worried about risk. And the sources make a really interesting distinction between risk and uncertainty.
This is a crucial distinction. Uncertainty implies a lack of knowledge. You don't know what's going to happen because you haven't done your homework.
So if you don't know the soil conditions, that's uncertainty.
Right. And the antidote to uncertainty is research. Go drill a hole. Do the test. Eliminate the unknown.
Risk, on the other hand, is different.
Risk means we know the probabilities and the consequences. We know there's a 10% chance of an earthquake. We can't eliminate it, but we can manage it. And the sources break risk down into specific categories.
There's engineering risk like soil conditions or fault lines. That's the stuff we usually think of.
But then there is political risk. Will the government change? Will permits be denied? Imagine spending millions on design only to have the city council vote no?
And social risk. This is the not in my backyard crowd, the MMBYs.
That is often the wild card. A project can be engineered perfectly and financed perfectly, but if the neighbors protest or if the community rises up against it, the project is dead.
So what does this all mean for the modern engineer? It sounds like we can't just be the hero who comes in, conquers nature, builds the bridge, and rides off into the sunset.
That hero archetype, the 19th and 20th century engineer bringing progress, is evolving. The sources talk about a shift toward integrated sustainability assessments.
We have to look at the triple bottom line.
Right. It's a balancing act. You have the economic leg. Is it low cost and profitable? You have the technical leg. Is it safe and durable? And now you have the social environmental leg. Is it non-toxic? Is it user-friendly? Does it maintain ecosystem integrity?
And there was a framework mentioned called the 7 Questions to Sustainability.
Wait.
I like this because it moves away from just profit to asking some really human questions.
It was developed by the MMSD task group. Instead of just asking, how much does it cost?
Yeah.
Question number 1 is, are engagement processes in place?
Our engagement process is in place. That sounds like corporate speak, but it basically means, did you talk to the people who actually live there?
Precisely. Question 2 is even more direct. Will people's well-being be maintained? It forces the engineer to look at the community impact.
The sources gave a real-world example of this. The groundwater replenishment system in Orange County.
This is a classic case. They were taking wastewater sewage and turning it into drinking water. Technically, it was brilliant, but socially, that is a hard sell.
People call it toilet to tap.
They do. Yeah, I wouldn't want to be the marketing guy for that. Here, have a glass of recycled water.
Not the easiest pitch.
But because they applied these sustainability questions, because they focused on public engagement and well-being, they were able to gain public acceptance. They proved that the yuck factor could be overcome by transparency and clear benefits to the water supply.
It really shows how the job has changed. You aren't just calculating flow rates, you're managing public perception.
If we connect this to the bigger picture, the engineer today has to be a diplomat, a financier, and an ethicist. You have to pass the technical exam, yes, but then you have to pass the glass of beer test to get hired.
Then you have to navigate the can-be leasts and the concretes who want to cut costs.
And finally, you have to answer to the public and the environment. It is a lot of pressure.
But it also makes the profession so much more vital. It's not just about keeping the building standing, it's about making sure the building should stand.
That is the ultimate takeaway. Engineering practice isn't just about calculating the load on a beam. It's about navigating the interview, upholding ethics when the boss wants to cut corners, balancing the budget against the you-pay-me architects of the world, and ensuring the project is sustainable for the future.
So here's a question for you to mull over. We talked about concrete versus MI green. Concrete says the green building costs $100 million more upfront. The math says the net present value is negative. Financially, it's a loser.
But MI Green says it saves the environment.
Exactly. So do you build it? At what point does the hero engineer have to bow to the financial reality? If the math says no, but your conscience says yes, who wins?
That is the question that defines a career.
If you haven't already, get over to our YouTube channel, Mechanical Engineering Made Simple, where we post hands-on how-to videos, visual breakdowns, and practical engineering walkthroughs you can actually use. A family that solves together stays together.